The Parker Solar Probe team is kind of blowing everyone away with some unprecedented findings about the behavior of our sun, solar wind, and the star's peculiar magnetic field. Since its launch in 2018, the Parker Solar Probe has been busy collecting data to help answer some of the biggest unsolved mysteries about the star at the center of our solar system. As a refresher, Parker is a highly specialized craft that is capable of getting us closer than ever to its surface. This new batch of record-breaking data was collected by the probe between late 2018 and April 2019 after completing just 2 of its 24 planned flybys, where it managed to get just 38 million kilometers away from the star. So far, the Parker team has been focused on measuring the behavior of the solar wind, the sun's constant outflow of charged particles. While these solar particles do eventually reach our humble blue planet, they really can't tell us much about the solar wind and the complex systems on the surface of the sun. So what exactly has Parker found that's got everyone so excited? Well, from its close vantage point to the sun, the newly collected data has presented the possible source for slow solar wind, a phenomenon that has been a long-standing mystery within the scientific community. Not to be confused with fast solar wind, which scientists know a lot more about. These winds travel between 500 and 1,000 kilometers per second, and they come from large coronal holes at the sun's north and south poles. Slow solar wind, on the other hand, moves at speeds less than 500 kilometers per second, and its source has remained unknown until now. After spending roughly a week observing the coronal holes, areas of colder, darker, low-density plasma, Parker was able to strongly correlate coronal holes located near the sun's equator to the origin of slow solar wind. But that wasn't the most surprising part. Parker also revealed a previously unknown feature of the solar wind. The probe's measurements found rapid reversals in the direction of the magnetic field, which moves outward from the sun embedded in the solar wind. Known as switchbacks, these phenomena bend back on themselves in moments that can last anywhere from several seconds to several minutes. Parker observed that these switchbacks occurred quite frequently, causing the slow winds to accelerate and form long tubes of fast wind containing plasma with around twice the energy of the background solar wind. Researchers are speculating that these energetic bursts could help explain why the sun's atmosphere is so much hotter than its surface. But more research is needed before we're able to know for sure. All of this is to say that this brand new information is making us completely rethink the physics of the sun. Scientists hope that Parker's subsequent flybys and further data analysis will help them build models to understand and predict space weather in order to better protect astronauts and avoid disruption in our satellites and electrical grid systems.
So what we learned from Solar Probe will definitely play very seriously into our understanding of space weather, of the dynamics of the Earth's magnetic field, the communication networks, the power grid on Earth is an extraordinary complex electromagnetic system. And so having big disturbances from the sun that can generate large currents in our power grid, in our communications grid, is potentially a very serious thing.
Now, Parker's data on the solar wind and weird magnetic field wasn't the only thing that took scientists by surprise. It has long been suspected that the area around the sun is completely void of cosmic dust. That's the stuff left over by celestial collisions from the formation of our galaxy. The long-held theory suggested that as dust approaches the star, it's heated to high temperatures and turned into a gas, resulting in a dust-free zone at roughly 3 to 4.8 million kilometers from the sun. And the Parker probe just found the very first evidence of this cosmic phenomenon. Its imaging instrument, WHISPER, looked out onto large sections of the corona and solar wind, observing dust that started to thin out at roughly 11 million kilometers. And this decrease continued until WHISPER hit its limit of what it could measure, at around 6 million kilometers from the sun. Scientists expect to explore this preliminary finding in more detail as early as 2020. As Parker continues on its 4th flyby of the sun, what's really amazing is that all of this data came from the spacecraft's first 2 flybys, so who knows what they'll find next, especially since Parker still has 21 more approaches to the sun. And by the end of its journey in 2025, it will have completed 3 full orbits, coming within roughly 6 million kilometers from the sun's surface. The hope is that Parker will continue to bring scientists one step closer in decoding some of the key mysteries about our sun. And for Bale and his team, they simply can't wait.
We wrote our proposal to NASA about a decade ago, and we've been working essentially around the clock. And so to see this data, it's just a pleasure. I mean, the data is so spectacular. It's a big case of delayed gratification, but it's really terrific stuff.
If you want to learn more about the Parker Solar Probe, check out this episode here. So what else do you think the Parker Solar Probe will find? Let us know in the comments below. Make sure to subscribe, and thanks for watching.